Lecture 7, Power Dissipation and Energy in Electrical Circuits. So what are energy and power? So in an electrical circuit, if I have a voltage source connected in a circuit is an element, then the current will start to flow through the circuit. And due to this flow of current, electrical energy will be transferred from source to the element. And this electrical energy per unit time is called as power. So basically, power tells us how fast energy is being used in the circuit. The formula for power is simply voltage into current, and the units are watts. So this circuit element is basically a resistor, and in the circuit, the property of resistor is to consume power. It can consume power either in the form of heat or in the form of light. It does not store any energy. So let's move on to the power expressions using Ohm's law. So power is equal to voltage into current, and as per Ohm's law, V equal to IR. So this expression can also be written as I is equal to V by R. So if I put the value of V in this expression, then the power expression becomes I square R, and if I replace the value of I in the expression, then it becomes equal to V square by R. So now we have three expressions of the power. So let's move on to the electrical energy. Electrical energy is basically power into time, and the unit of power is watts and the time is seconds. So the unit becomes watt second, which can also be called as joule. But the practical unit of energy is 1 kilowatt hour. It is the unit based upon which the consumers are charged at the households. So what is 1 kilowatt hour? So it can be understood by this example. So if I have a 1 kilowatt rating electrical kettle, and if I run it for 1 hour, then the energy consumed by this electrical kettle will be equal to 1 unit or 1 kilowatt hour. So let's understand all these things with the help of a numerical. So if I have a 10 volt source and a 5 ohm resistance is connected, we have to find out the value of phi, power and energy in 10 seconds. So what is the value of phi? It can be found out with the help of Ohm's law, that is V by R, and that is 10 by 5 is equal to 2 amperes. Now the power is simply voltage into current. Voltage was 10, the current is 2 amperes, so the power comes out to be 20 watts. And finally, what is energy? Energy is equal to power into time. So power is 20 watts, time is equal to 10 seconds, so the energy comes out to be 200 watt seconds, which can be written as 200 joules. Let's summarize lecture 7, power dissipation and energy in electrical circuit in a flowchart form. So in an electrical circuit, if voltage V is applied across resistance R, then current I will start to flow, and due to this flow of current, energy is transferred from voltage source to the circuit element. The energy transferred per unit time is called as power, and the formula for power is simply V into I. V into I, and the units are watts. So we can rewrite this formula P is equal to V into I using Ohm's law, and Ohm's law says that V is equal to IR. So it can also be written as I is equal to V by R. If we put V is equal to IR in this formula, the power becomes I square R. If we put I is equal to V by R in this formula, the power becomes V square by R. So power used over time is known as electrical energy. The formula is power into time. So the unit becomes watt for power into time, that is seconds, that is watt seconds, which is called as joule. But the practical unit is called as 1 kilowatt hour. That means that if you run a 1 kilowatt electrical kettle for 1 hour, then it will consume 1 kilowatt hour of energy. Then there was numerical in which 10 volts supply was connected across 5 ohms resistance. Then what was the value of current I? The current I is simply V by R, that is 10 by 5 is equal to 2 amperes. What is the value of power? Power is equal to V into I, that is 10 into 2, that is 20 watts. And what is the value of energy in 10 seconds? So energy will be equal to power, that is 20 watts into 10 seconds, that is 200 watt seconds, which can be written as 200 joules.